range is the max minus the min.
Mhm.
So it's two numbers. You gotta be able to subtract them. Now, the questions I'm going to give you are never that simple, but in the first couple, you are actually calculating the range. You just have to figure out what it is that you're calculating the range of. So in general, you don't want to look at the table information. It's just distracting. So we're just going to focus right here on the. So for which of the following surfaces is the range of albedos the greatest? So everything in this table is an albedos, but there's actually 1, 2, 3, 4 of them. 1, 2, 3, 4, 5. So they're actually giving you the max and the min. So you would almost want to calculate the range of each one. What would the range of that first one be?
0.08.
Yeah, 0.08. And how about for the next one?
0.08. Okay, the next one is 0.08.
Okay. Yeah, and if you need to, you can think of it as like 34 minus 22. That may shorten that up for you a little bit.
Okay.
Can you tell me the next one?
0.12.
Okay, keep going here. 0.26, 0.29.
0.03.
Okay. And then the last one there, 0.84, 0.41.
.43.
Yeah, now which is the greatest in this group?
Snow, 0.43.
Yeah, now when you look at this question, now that you know the answer, do you think you could have maybe done that faster by looking for the biggest spread of numbers?
Yeah.
Yeah, and that's kind of what you want to do here. I mean, it is okay. It is definitely okay to it is definitely okay to do them all, but you just got to be careful that you don't waste time doing that. So let me see if there's another one like this one. And fortunately, there's not. Okay, I don't have another problem like that. So we're going to move on to one that's kind of like it, and then we'll talk about box plots. All right, so pull up this next question. Is this big enough on your screen to be able to see and read and all that?
Yeah.
Okay, fantastic. Okay. So I always recommend going right to the question. What is the range in meters of these 5 trench depths? Okay, so I want you to tell me which of the 5 is the max and which of the 5 is the min.
Okay, the max is Mariana.
Okay.
And the min is Kermadec.
Okay. Now let's see if we can do this without a calculator, just looking at the two numbers, 11,033 and 10,047. Can you rule out any of the answers immediately? Like 151, 533, 835, 96, any of them just, and really what I'm asking you to do is to estimate here what the answer is approximately. Like this is like 11,000 and this is like 10,000.
I would get rid of A.
A for sure, and actually B is also pretty unreasonable as well.
Okay.
So I know as a student you probably want to work these out, right? But you got to find ways to work through these without doing the calculation because it takes takes too long. Now, how far apart are 835 and 986 approximately? Like, are they, 5 apart, 10 apart? How far apart are the numbers?
Like 150.
Yeah, I like that. Yeah, good. So to me, they're pretty far apart. And that's why you can almost go to D right away and say, okay, it's probably D because they're 150 apart. We said the difference is about 1,000. 150 is pretty far off from 1,000 in terms of the difference. So that, like, the point though is to use some estimation to be able to get your answer much more quickly. Okay. So let's talk about some box plots. Have you done any box and whisker plots in your stats class?
Yeah.
You have. Fantastic. Okay. So let me just ask you a few questions. You will not have to create a box plot. So that's one of the misconceptions is about this test is you don't actually do many of the calculations. You have to be able to interpret what you see here. Okay. So for data set A, could you tell me the min and the max for data set A?
The min is 10 and the max is 140.
Yes, 10 and 140. So what would the range be?
130.
Yes. Okay. And for B, can you tell me the min and the max?
The min is 80, the max is 160.
Okay. And what about the range for this one?
The range is 80.
Okay. So now looking at the data set A compared to B, which has a greater spread, A or B?
A.
Okay. Now let's go and actually look at what the question asks for, because it may ask something as simple as that. It may ask for something more sophisticated. So let's take a look here. I'll snip the whole question in here. Okay, it says each of the box plots shown summarizes a data set. Data set A has a range of 130 and data set B has a range of 80. We just calculated that. If the two sets are combined into one data set, what is the range of the combined data set? Tell me what you think about that, or what, if you have questions, or if you can just answer it. What is the range of the combined data set?
Oh, so does that mean you subtract 160 from 10?
Yes.
Oh, okay, so it's C.
Yes. Because it's the combined one. It's almost like you look at them now together.
Okay.
Okay, very good. So let's look at another one. 15, yeah, okay. All right. Oh, so before we do this one, so what's your favorite swimming race that you do, or your, like,
The 200-yard freestyle.
200-yard freestyle? And what's a kind of a good time for you to do the freestyle?
2 minutes and 5 seconds.
2 minutes and 5 seconds. So we'll say 125 seconds. So let's say you ran the race, or you did this a couple of times, and you had 125, 126, and then 127. Okay. All right. And I'm not a very good swimmer. So, well, I'm not very fast. So I probably would take a lot longer. I'll be generous here and say the first time it took me 200 seconds, then I got tired, and then I got even more tired to do it.
Okay.
Okay. Which data set has more spread in it?
Yours, the 200 to 280.
And why? Why would you say that?
Because the first data set, the range is 2, and the second data set, the range is 80.
Very good. Yes. So in some ways, range, what's called range and standard deviation are very much the same. Meaning the one with the greater range has greater standard deviation. Greater standard deviation means greater range.
Okay.
Okay, so keep that in mind as we now look at this next problem. I'm not going to snip in the answers because it gets a little bit too much at first with this, but we'll do it this way. This is one of the benefits of doing it virtually is I can kind of ease you into the questions rather than overwhelm you. So what I want you to tell me is which data set has a greater range or standard deviation, because they're essentially the same.
Data set B.
Yes. Okay. Now, let's snip in the entire question with the answers. And this is one of those which of the following. So you got to kind of look through them all to decide if there's one that matches what you think the correct answer is.
A.
Yes, that's right. Very good. Okay, here's a problem to try completely on your own without any input from me.
D. Data set D.
Okay, and how confident are you in your answer?
I'm confident.
Yeah, I would agree. It's perfect. Okay, so those aren't too difficult, right? And you're like, oh, I got it, right? But there's other types of problems that they can give you. And so now it's more about like, can you interpret tables? Can you interpret graphs here? So what I want you to do, actually, let me just snip in the tables first. Because, and this is really how you should work through these problems, is you should spend a bit of time trying to figure out like what exactly is going on in this table before you read the question as well. It's like sometimes you're like, okay, well, what does this mean? So city A, they have 3 frequency, maybe 3 days of temperature 80. And city, and then 14 days at 79, and then 2 days at 78, and 1 at 77, 1 at 76. Okay, so the data set looks like this: 76, 77, 78, 78, 79 to 79, but there's 14 of them. And then 80, 80, and 80. So going back to like the swimming example, where is most of this data centered around? Where is it kind of clustered around?
Oh, 79.
Yeah. So another way you could sort of graph this is what's called a dot plot. Have you been doing those at all?
A little bit, yeah.
Okay, now you really don't want to spend the time to do this, but what you want to imagine here is that there's a huge peak at 79 and everything else around it's kind of like this. Okay. I don't know if you can visualize that from the data. If you turn, it's like you could make one kind of going like this way as well, where you
Okay.
have the bars go out horizontal. But let's compare that to the one below. So it's got a 6, it's got a 3, a 2, a 4, and a 6. So notice the range in both of these is exactly the same. But so you can't use that as a way to decide which one has more spread. You have to look at the numbers themselves. Like if they're clustered closer to the mean, like in letter A, that means it has more or it has a smaller standard deviation. Like it's more consistent.
Okay.
And this one is, it seems consistent, but it's more spread out across the 6 numbers, whereas the other in A, you're more likely to get the you're more likely to get something in this 79.
Okay.
I don't know. I hope that's not too confusing, but we do need to kind of know that stuff before we go and talk about the question. So like I would recommend making a little bar chart. It's really a histogram, but for each of these before before you move too much further. But let me snip in the question and have you try and answer it now.
Letter A.
The standard deviation which is A is larger. So again, A was the one that was more clustered around that 14. So it has less standard deviation. And B was like they're a little more spread out, even though they have the same range. Okay, that didn't mean much to you, did it?
No, I'm sorry. I'm kind of confused.
Yeah, I can see that. All right. Let me go to next question here that's got the dot plots because it's better.
Okay.
And we might need to switch. Okay. Okay, so let's use a different way of thinking for this problem. Instead of height, let's call this quality in each of these. Like you're going out to eat and you want quality, okay? Which of these 4 graphs is the most consistent with quality? And when I say consistent, like you expect, like you get kind of the same result every time you go.
Oh, data set D.
D, yes. So this is the most consistent, meaning that like you have a target and you hit it over and over and over and over and over and over and over again, okay? This one has a low standard deviation. Okay?
Okay.
Because like every time you expect to get the same thing. Expect. All right. Now, which data set has the worst quality, or I'm not the worst quality, the most inconsistent quality? And there may be more than one answer here, but give me your answer and why.
Data set A.
Okay. I would argue A kind of is clustered around this area.
Mm-hmm.
And so like I was looking for either B or C, and here's why. So in B, like you could go in one day and get a 64 rated meal or a 78 rated meal. And
Oh,
anything
okay.
in between. And you don't know. It's just it's a pure guess. It's very wild. It's not predictable.
Okay.
Same with C, 66, 70, 74, 78. Like you don't know whether you're gonna be on the low end or the high end or somewhere in between. A is kind of clustered, although it's not great in there. But what I'm trying to, and I think you got it is that the lowest standard deviation is when they're most clustered together.
Okay, so B would have a higher.
Yes, B would have a higher one.
Okay.
So
Okay.
going back to our previous question, because A has most of the answers or temperatures at 14 or at 80, so I'm sorry, 79 at 14. It's like everything is dotted around that number.
Okay.
And that's why A has a lower standard deviation and B has a higher one than by that. Okay, so now let's go look at this question. And this is our last one of these. We'll move to a different topic. So let me, okay. Go ahead and see if you can answer this one for me, please.
D, data set D.
Smallest standard deviation, yes. Data set D. Very good. Okay. All right. Okay, so we're going to move to some ratios from figures, and these ones are very, very fast potentially. I don't think we've done these before. They're kind of probability. You had some tables, and maybe in your statistics course, something like this. Does this look somewhat familiar?
Yes.
Okay. So let's look at this here. The table above shows the kinds of food that are fed to the cats and dogs currently boarded at a pet care facility. What fraction of the dogs, so they're saying just the dogs, are fed dry food? What do you think here?
So the amount that are fed dry food are 2.
Okay. So that means we're either down to A, B, or D.
And then so it's either 7, it's either B or D.
Okay, I agree. Yeah. Now, like, keep in mind here, it says what fraction of the dogs, that means you just care about, well, let me say it differently. Do you care about cats?
No.
You just care about dogs.
Oh,
So-
so it's
so-
25.
Yeah, and I know you don't have a highlighter, but I mean, that's what I would tell you to do, is be like, all right, it's just that right there. Yeah, it's 2 out of 25. Okay, let's try another one here. Now, and another thing I'll point out is here, they give you the total, both of these. Sometimes they do not give you the total, so just be on the lookout for that, because you may have to
Okay.
calculate it yourself. But let's look at another one here. All right, here we go. You see that okay? Is that clear?
Mhm.
All right. The table above shows the distribution of age and gender for 25 people who entered a contest. If the contest winner will be selected at random, what is the probability that the winner will be either a female under age 40, or a male age 40 or older?
Okay, so there are 8 females under 40 and 2 males 40 or older.
Okay. Okay, so that's 10. 10 total, right?
Mhm.
So
So
what's the
B.
denominator? Yes, B. Now, one of the things I found interesting when I was looking at this is that they do not reduce.
Mhm.
And I guess I'll say this, they'll never have like 2 answers where like one is the reduced versus the non-reduced. So if you ever feel like, oh, those are the same, it's because you're making a mistake. These things are checked pretty well. Like 10 out of 25, they both are divisible by 5. But I think they're choosing to not reduce it for like just to be different in this problem, but
Okay.
it's just the way it goes. Okay. Let's look at this one. Sorry, my screen is just frozen for a moment. So are you really doing yards and it's not in meters when you're swimming? Is
Yeah, it's yards.
Oh, really? So cool. Okay, so never read the top part. Go right to the question. How many of the males surveyed responded that they do not play a school sport? So that's the question mark. They're like, what number goes in there? And that's when maybe you go back and you read this beginning part. So notice they do not give you the total.
Mhm.
What is the total in this problem? Of all the
1,000.
students? 1,000, yeah. Now let's see if we can kind of estimate the answer. Okay, so let's take 1,000 and let's subtract 300 for that first group. And then 220 and 216, maybe call that like 450, like that,
Mhm.
roughly. And you're subtracting these. So 1,000 minus 300 is 700. 700 minus 450 is about 250. Now I would be super confident in selecting B.
Mhm.
Do you see how it's very far away from A and C?
Yes.
Yes. And that's by design. Like a lot of times they give you enough room to be able to estimate rather than having to do the calculation. I don't know if this is a calculator, no calculator. But that's the kind of thing that I would want you to be able to try to estimate the answer of.
Okay.
Okay. All right, so let's have you try this one on your own. Grab a snip of it. Again, go right to the question. Don't get, or you can look at the table, but it's also a good idea to just go right to the question and then look at the table right here. You don't necessarily need to read the fine print quite yet.
Letter B.
Okay. How confident are you in your answer?
Pretty confident.
Yeah, so they want the ones from Valley High School. You're looking at just this column. I would recommend circling the one that you're supposed to be focusing on. And yeah, it's 65 out of 140. Again, notice it's not reduced.
Mhm.
I don't know why. I mean, it's just the way it goes. All right, let's look at another problem here. I'll have you try this one on your own. And I think sometimes they choose topics that are like unclear, like things you've never heard of, like an Alaskan Malamute.
Mhm.
But you don't even want to think about that. You just want to be like, it's a table, there's data in it. I got to figure out which numbers it is, which numbers I'm using, things like that. So go ahead and take a look at um,
Letter B.
okay. So how did you come up with that?
So
I'm not saying you're wrong. I'm just asking how you came up with that.
if it's selected at random, then you have to find the total. So the total of both of the breeds is 20.
Agreed.
And what you're trying to find is an Alaskan Malamute, which is 8 across both of
Good.
them.
Yep.
So that's 8 out of 20. And then you
Perfect.
multiply each side by 5, and that's 40.
Oh, well, so this 8 out of 20, you've got to be able to convert to a decimal. Because if you multiply the bottom by 5 and top by 5, that gets to be out of 100. I think we talked about that. Is that what you meant?
Yeah, yeah.
Okay, yeah, perfect. Yeah, that's excellent. Okay. Very good. I like your thinking. That's all right, so let's have you try another one here. Are these difficult, by the way?
Not really.
Yeah, and you'll get a fair number of these table questions, so these are nice to see. All right, go ahead and work this one out, please.
Letter D.
Okay, so we're looking at batch 2. Okay, if an item from batch 2 is selected at random, so when they say that from batch 2, they're actually saying restrict your
Oh, okay.
population to that right there. Like that's all you care about now.
Okay, so letter B.
Yeah, 20 out of 60.
Okay.
Let's see here. Let's get another one of these. Like there was one more. Yeah, this is a good example of like, don't get caught up in the complicated species name. Just just match it up, or don't even just call it, use the first letter in the word, like, oh, it's a
Okay.
P. It's a P, not a paramiliphory. You have an answer for me?
So for this one, are you to find the denominator, do you add up the Australian species?
You do, but what I would tell you to do is kind of estimate it, because the denominators are, they're given here. Like it's like 137 and 70, that's about 200, and there's a little bit more, so it's probably 235.
Okay.
Now you could add them up, and I know you want to as a student. You're like, okay, make sure, but like the test is designed so that the answers are far enough apart that you really wouldn't have to.
Okay.
You really wouldn't get into there. It's not like 236 was another denominator. They're not trying to like get that close in these.
Okay.
Okay, last problem in this grouping, and then we'll move to something else. This one you can definitely use a calculator on, whereas the others are kind of maybe not. This one's designed, oops, this one's designed to be done with a calculator. Take a look at that.
Letter B.
Letter B. And how confident are you in your answer?
I'm confident.
Okay. What numbers did you divide?
I divided 854 by 165.
Okay. So the public middle school will be selected from the two counties. What is the probability to the nearest hundred of selecting a school in the San Diego County? All right, so I went actually the wrong way. This is the right way here. They're saying they're going to select a middle school, and they want the one from San Diego County.
Okay,
So
so
it's actually 165 out of 587, which will change your answer.
to C.
Yeah. So they do give you both. Like it's not the case where you can get lucky and just only if your number is there, it works. The language you're looking for is like whatever they're restricting to. And in
Okay.
this case, it's a public middle school, not the county. And that's an English language thing. Like somehow you have to read that and be like, okay, we're talking about middle school, not the county. Okay, so let's switch topics here for the time we've got left, and give you some more of these problems. So we're going to move to expression problems.
Okay.
All right, here we go. Okay, so it says 1 pound of grapes costs $2. At this rate, how many dollars will C pounds of grapes buy? So sometimes it's a good idea to make a table. To help you see the pattern. Basically, this is a pattern which leads to an equation.
Okay.
So for example, pounds and then dollars. So let's say you want to buy 1 pound of grapes. How much does it cost? $2. That's the first sentence there. So if you buy 2 pounds of grapes, how much will that cost?
$4.
Okay, and 3 pounds?
$6.
So what is the pattern? How do you go from pounds to dollars?
You multiply the pounds by 2.
By 2. So if you have C pounds, it would be
2C.
2C. And so you got to go out when you're doing patterns, you have to go out far enough that you can see it, because if you go like B works for the first 2, well, kind of. I mean, it works for the second one. Just you want to go out far enough that you actually can say for sure it is that it works for that. And you were doing that when you learned how to do equation writing a couple years ago. Okay, we got a song about downloading and streaming. Are you a Spotify? Is that the preference now? Spotify?
Yeah.
Yeah, right. We don't really download anymore, but these questions sometimes aren't all that relevant. But go ahead and take a look at this one. There's no calculations, it's just writing an equation.
Letter C.
Yes, so you're literally just matching up the amount with the variable and with the other variable. Okay, and sometimes it takes longer to actually read it than to do it, do the actual calculation here. which is just writing at this time. Okay, so if you try one more of these, and I'll give you a slightly more difficult one after this.
Letter C.
Yes. All right. So these are just writing the equation. There's no solving, and they're going to get at least one of these types where you just have to put together the expression. So here's another one that again, a lot of words, but you kind of do have to work your way through the whole thing. Sometimes going right to the question doesn't help because you end up having to go all the way back to the beginning anyway to answer it. But take a look at this one, see what you come up with, and then we'll maybe move to some more numerical ones.
Letter C.
Yes, that's also correct. Very good. All right, so remember last time we talked about making a table of the answers?
Yes.
All right, so um, when we did that though, like usually you had the equations, and in these problems we're going to look at, you are not going to have the equations, so you're going to have to do a little bit of manipulation to be able to get them. But I've got at least two problems here that we can do with a table. So it says between 1497 and 1500, Amerigo Vespucci, whatever, Amerigo V embarked on two voyages to the New World. According to V letters, the first voyage lasted 43 days longer. That's really important than the second voyage. And the two voyages combined to 1,003 days. How many days did the second voyage last? So here's the second. How does the first compare to the second? What was
The first one is 43 days longer.
Yeah, so we've got to add 43 to each of these, okay? And the faster you can do that, okay, the faster you can get your answer, okay? Now here's what you do not want to do, and this is over here to the right, because you're writing a system. X plus Y equals 1,003. X minus Y equals 43. You don't want to solve these, okay?
Mhm.
What you want to do is build a table and realize that the total is supposed to be 1,003.
Mhm.
So which is the correct answer? Which of these adds up to 1,003?
Letter B.
Letter B. So this table, whenever you see a system, you really almost always want to make a table, unless the system can't be solved, unless there's like really trickiness to the system. But the table method really does work quite well.
Okay.
All right, so let me get this next problem up here. I got to add in the multiple choice. So let me do that first, and then I'll snip it in. I want you to make a table for this one. Okay. All right, so I'm trying to help here by making this up. It doesn't completely work, but let's assume that this is Laura here.
Okay.
And I want you to try this using the table approach.
Okay, so she spent 105T.
Oh, sorry, this is written wrong. This should be Doug. But yeah, so the Doug is 40 more, right? So I think you were maybe going this direction. And then one of these adds up to
250.
200, 250, and that's the last one. Yeah. So just another technique, right? Like there's none that works on every problem. You just have to look out for these things to save you some time. That's why we're doing the practice that we are. Because the problem itself is not that difficult. It's just you don't want to spend a lot of time on something like this if you don't have to.
Okay.
All right. Well, that does it for us for tonight, Julia. Thanks for scheduling. Thanks for letting me help you, and be happy to help you again. Let me know when you're ready to schedule, and we'll either do it in person or like we did here.
Okay, thank you so much.
You're welcome. Have a great night. Bye now.
You too. Bye.